At least 3 times per block is a science sit rep. Again, situational report. This is partially an operational status, reporting back if they missed any targets or gotten any specific ones. If they have issues with their camera or any other operational items. The other part is an actual description of the moon. This task is done by one of the support team astronauts, so that's not the crew currently taking photos or making annotations, but they do have windows 1 and 4 that they can float up and provide that information from. If you watch the entirety of the flyby, you'll also notice the crew will be photographing some targets multiple times to get observations in different lighting conditions. This is due to Orion changing their location throughout the flyby. What this crew will be able to capture in a couple of hours of the same targets in different lighting would take orbiters years to do because of solar and spacecraft positioning. This crew has studied the moon extensively, and they're also familiar with what the science team calls the Big 15. These are 15 features that they've memorized, so at any time, they'll be able to see 5 of those and help orient themselves and where they are around the moon. Those targets are diverse and complex in their geologic history, and observations of them could help answer some big picture science questions. If you've been following the mission, you can see that the configuration of the cabin is a little bit different than what it looked like on launch day. After ascent, the crew were allowed to reconfigure their
10分です。
spacecraft, and you can see that they've taken down seats. They have also taken away footrests. This gives them more opportunity to move about the spacecraft. Orion itself has 330 cubic feet of habitable volume. That's about the size of 2 minivans and is 60% more cubic volume than the Apollo spacecraft. We are standing by for the Integrity crew aboard Orion to surpass the Apollo 13 record.
Integrity crew, on April 15, 1970, during the Apollo 13 mission, 3 explorers set the record for the farthest distance humans have ever traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
Yeah, from the cabin of Integrity here as we surpass the furthest distance humans have ever traveled
ア
from
ポロ
planet
の
Earth.
記録を超えまし
We
た。
do so in honoring the
人類が
extraordinary efforts and feats of our
今ま
predecessors
でで一番
in
遠く
human
に来ま
space
した。
exploration. We will continue our journey
アポ
even
ロ
further
13
into space
記録を
before
超え
Mother
ました。
Earth succeeds in pulling us back to everything that we hold dear. But we most importantly choose this moment to
あっさり
challenge
してるね。
this generation and the next to make sure
ま
this
あ、この
record
後
is
がね、
not lost.
月の観測の本番ですから、まあ、そっちがね、メインイベントなのかもしれないけれど、私にとっては、この瞬間が一番かな。
Thank you, Integrity, and congratulations to you and the rest of the ArtemisII team.
couple more things we'd like to take this moment for. Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens, and so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft integrity. And so if you were to look at Oriental on the far side and then draw a line straight up to Ohm on the far side, relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary, and so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reed, the mother of Katie and Ellie. And if you want to find this one, you look at Glushko, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol, and you spell that C-A-R-R-O-L-L.
この宇宙船はもう誰も飛んだことのない距離を飛んでるんです。すごいよね。
Integrity and Carol Crater. Loud and clear. Thank you.
だよね。
As the Artemis II crew passed the record set by Apollo 13 for the farthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, Canadian Space Agency astronaut Jeremy Hansen shared.
We're getting ourselves all put back together now, and we are going to dim the cabin lights and prepare for our science objectives ahead.
Sounds good. We're doing the same down here, and you are maneuvering to your observation attitude.
As we pass that Apollo 13 record of the furthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, the Artemis II crew shared some poignant words, specifically Canadian Space Agency astronaut Jeremy Hansen. The crew also called down 2 craters not yet named that they would like to name. One, Integrity, in honor of their spacecraft, which they have named. That's near the Ohm crater. Another near Glushko, which is a bright spot, named Carol, in memory of Reed Wiseman's wife. There was a moment of silence here in Mission Control Houston. And now the team and the Artemis II crew are ready to begin their lunar flyby. We are 4 days, 19 hours, 31 minutes mission elapsed time of the flight of Artemis II, our 4 astronauts aboard Orion. Today is our lunar flyby day. The spacecraft is currently about 12,000 miles away from the moon, and you can keep up with the distance from Orion to the moon and Earth by visiting nasa.gov/trackartemis, or you can just stay with us here because we're going to be telling you throughout the day. They are currently 248,834 miles away from planet Earth. Coming up next on the crew's timeline today will be their cabin configuration portion. You heard some calls down to Science Officer Dr. Kelsey Young earlier about how they have configured the cabin so far. This is just a little bit more of timelined activity for them if they need to further do so.
ちなみに、
On flight day 3, the crew had time on their schedule allotted for configuring the spacecraft cabin for how they intended to arrange it today. Of course, they had to take down that configuration for another test yesterday of their Orion crew survival system suits. But configuring it on flight day 3 allows them the
ね、
opportunity
もうすぐ
to
月
get
だ。
a chance to see what works for them now that they are in the
どっ
microgravity
ちかってい
environment.
うと、月が迎えに来るみたいな感じかな。そうね、アポロ13号の記録は超えたのだけれど、まだまだオライオンは、アルテミス2のね、宇宙船はもうちょっとまで進んで、で、そうね、その後月が迎えに来て、で、月に引かれて、で、くるっと U ターンする。まあ、フライバイっていうね、いうことをする。
Again, the crew is about to begin their cabin configuration portion of their timeline, though they have been working that already, as well as potentially during their post-sleep period this morning. The official lunar flyby observations are slated to begin in just about 40 minutes. That's when we'll have the crew at the windows photographing the moon, as well as making calls down about what they are seeing. Again, we are live here in Artemis Mission Control for the duration of the flyby. Currently, the Orbit 1 flight control team is on console. This room is staffed 24/7 from the time before the astronauts step foot on the rocket until the time they are splashed down and are safely recovered in the Pacific Ocean on flight day 10. Again, this is Artemis Mission Control here in Houston. We are now 11,777 miles away from the moon. We did pass the Apollo 13 record of farthest humans away from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance, 248,655 statute miles from the Earth, continuing to be exceeded by the crew. They will reach their farthest distance from the Earth around 6:07 p.m. Central Time. At that time, they will be in an LOS, or a loss of signal, with us on Earth, as they'll be flying behind the moon. As the crew gets into their cabin configuration preparations, we are joined by Dr. Sarah Noble, the Artemis Lunar Science Lead. Thanks for joining us here today.
Yeah, it's quite a day.
Yeah, we are very excited. I can only imagine how you guys are doing over there. So tell me a little bit about yourself and what your role is for Artemis II.
Sure. So I'm the Artemis Lunar Science Lead, so over the entire campaign, and my job is basically to make sure that as we have this big adventure back to the moon, we actually learn new things about the moon.
Fascinating. So why is the moon such an important destination today?
Yeah, so the moon is a pretty amazing place. It is a great place to learn about basic fundamental processes that happen on like all the planets, like cratering and volcanology. And also it is, part of our Earth-Moon system. And, the Earth recycles its rocks pretty well, right, through plate tectonics and weathering and whatever. Most of the rocks on the Earth are geologically young. But on the moon, we have the entire record that goes back 4.5 billion years since we formed. And so if we really want to learn about what was happening in that period, like the moon is really the only place we can go.
We're also thinking about going back to the moon, and we want to go to the lunar South Pole. So what makes that such an interesting destination?
Yeah, the South Pole is cool, right? It's far away from the places we went during Apollo. It's different kinds of rocks there, some of the oldest rocks on the moon. It's also a place where we think there might be resources like water. There are craters that really never can see the sun because of the low sun angles there, and they get very cold. And we think that water and other things can build up in those craters, and so we're very interested to see what that might do for us.
I'm very interested as well. So for some of our viewers who might be new to this, what does lunar science look like during an Artemis mission?
Yeah, it's pretty exciting for us as we have sort of built this from scratch to try to understand how we can best use the crew to support our science. And so, we've developed a system. We've got a team in place. We've got a back room here in this building called the SIR, the Science Evaluation Room. And there's in fact a back room to that back room over in another building here at Johnson Space Center where we've got our teams of scientists working really hard. They're actually speaking to this room through our science officer. This is now the first time we've ever had a science officer in flight control room. So we're pretty excited about that. So we have a really voice out and up to the crew.
I know, it's been so exciting to hear Dr. Kelsey Young speaking directly with the crew today, now so close to the moon. And we have a live view here of the science operation or the science evaluation room. So this is where the majority of your team is today. Is that right?
Yeah, that's right. This is a big chunk of our scientists. You can see them in there now working hard, trying to get ready for the day. And then again, there's a second room where we have a lot of our data folks, where the data will first come down and they'll sort of sift through the data and get it ready for this team to take.
What's the mood like right now in the SIR?
It is, I would say, giddy. I think we've worked very hard for this. They have done simulation after simulation. They have worked really hard over the last couple of years to get ready for this moment, and I think everybody's just really excited to see. Even already we've had some descriptions from the crew coming down, and it's so great to see their joy and our joy, our love for the moon come through.
Yes, we are in for a real treat today if it's been anything like their observations the past couple of days. So how are the lunar science teams using this test flight to prepare for future missions to the moon?
Yeah, absolutely. This is the way that we are building our foundation for the future, from everything from, how do you train a crew to be a geologist, right? And so, working through that, getting them classroom training, field training, building the science team, building these physical rooms that we are in, designing the software that the teams are using, and then, figuring out what happens to that data. They're going to take this data and it's going to come down, and how do we get it out to not only our team, but out to the world and the rest of the science community?
Yeah, that's a great point, because when you hear these crew members talk, you would never know that they're not geologists. Your team has trained them so well.
They have been very good students.
Who can blame them? It's a pretty great topic. One more question for you. How does the science that we're doing on Artemis help support long-term exploration and including our sustained presence on the moon?
Yeah, you know what? We have a saying in the Science Mission Directorate that science enables exploration and exploration enables science, right? So you need the scientists because we are the ones who are the experts in, landing site and doing analysis of landing site and making sure we can find a good place to land, to understanding the properties of the soil so we can, design our systems to manage that, understanding the radiation environment, keeping our astronauts safe, all of these things, right? But, in return, you provide us with opportunities where now we're going to be able to collect this data and collect samples and deploy our instruments and all of that. So it's a symbiotic relationship.
That makes perfect sense. Well, Dr. Sarah Noble, Artemis Lunar Science Lead, thank you so much for joining us here today. Best of luck to you and your team, and I hope that you get to enjoy today too.
Thank you so much.
We are now Getting closer and closer to our lunar neighbor, this live view coming from the Orion spacecraft and a camera mounted on one of its solar array wings.
Houston, integrity for camera serial numbers.
Ready to copy.
Hey Jenny, these are card numbers for the various positions. For the long lens on the D5, we will have individual cards. Victor's 1008, Jeremy 1019, Reed 1012, myself 1015. For the Z9, we will have one card that is dedicated for today, serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
ニコンの D5 で撮るよって言ってましたね。
We just realized that we have Earth out window 1 and Moon out window 2, and I'm sorry, Earth out window 4 and Moon out window 3, and it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reed.
Those are some of the communications we're excited most about today. Commander Reed Wiseman calling down their view right now. Obviously a little bit different than what we can see from the solar array camera. They are looking through the windows of the Orion spacecraft, able to see at the same time Earth and the Moon. You also heard NASA astronaut Christina Cook calling down some of the cameras that they will be using today. The crew is in that cabin configuration portion, and we expect the lunar flyby observation period to start in just about 20 minutes. Checking in on Orion's distance and speed. They are
実際
currently
に観
traveling
測を開始するのは
miles per hour,
日本時間の午前3時45分頃、
away from Earth,
あと20分って言ってましたね。
away from the moon, and continuing to grow closer. At closest approach to the moon today, the spacecraft will be just about 4,070 miles away from the lunar surface. This will be during our loss of signal with the crew as they travel behind the moon, and we will await their return to get the official number for you for how close they come to our lunar neighbor. Inside the cabin today, the lunar targeting package is the primary tool guiding the crew observations and consists of two key components. The Lunar Geography Review helped the astronauts study major lunar features in advance and help learn how to orient themselves during the flyby. Because, of course, the moon is not actually labeled like it appears here when we look at this map. The lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for the pictures the crew should take, as well as the verbal descriptions that will be helpful to the science team reviewing them later. This is a screenshot from their lunar targeting package, and a screenshot specifically of that lunar.
For attitude.
Go ahead.
Hey, Jenny. Understanding we are in final attitude now for the lunar flyby, would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
That call from Christina Cook, NASA astronaut and mission specialist on ArtemisII.
Copy.
The Orion spacecraft is positioned in a specific attitude to allow the crew to best see the moon outside of their windows today for this imaging opportunity. That call was a request for a potential attitude shift just slightly, another 5 degrees, to give them a better view and to give them a better opportunity to use their long lens camera. They'll also be using that lunar targeting package we were discussing. I am following along with that real time, so I'll be able to share with you exactly what targets the crew is looking at and when. They also trained with a lunar science passport. It's a little reference guide used on Earth to reinforce recognition of key lunar features. It is not on the flight, but it was a significant study tool for the crew to get them ready for launch. The apparent size of the moon will change throughout the flyby, and it'll appear roughly like a basketball held at arm's length at the crew's closest approach. That reinforces the need for careful planning and practiced observation techniques.
Houston, integrity for timeline.
Go ahead.
Hey, Jenny, just to make absolutely sure that we start observations when expected, we are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well. Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
Affirm.
今はいろんな、撮影とかの、タイムラインを確認しますって言ってますね。で、私カメラ系のあれなので、カメラはニコンの D5 みたいです。D5 のシリアルナンバー2台分確認していました。あと、ロングレンズって言ってるから、今、画像を出しているような、望遠のレンズを今回、アルテミス2では持ち込んでいます。80ミリから400ミリまでのものを使っているので、それでね、月面の観測をするってことです。で、観測もね、ちゃんと任務なので、大事なミッションなので、もうちゃんとね、ターゲッティングされていて、どこを取るよとかね、あらかじめ、計画通りに進めると。で、月の裏側に入ってしまいますから、そうすると通信ができません。それはね、まだ先です。それは1時40分頃なので相当先なんだけれど、その時にね、取るものとかもあらかじめ計画を立てて、で、あとは船内で、人間がいますから判断をして取るみたいなね、感じだと思います。
As you heard discussed, we are expecting the crew's observation time period to start in about 10 minutes. First, they'll be conducting a warm-up, warming up to their science observations of the moon. They'll be discussing with each other, helping each other orient using the major landmarks that they've studied, asking what is familiar.
If we roll left, port 5 degrees, that would get the moon closer to the left side of window 2.
Copy, Victor. We'd like to know if it's pitch and roll or one or the other.
We actually thought you already put the pitch in. Had the pitch been put in already?
No, we need a little while longer to talk about it.
So, Jenny, I guess what's happening is just as our orbit's changing, where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
Right now, we are pointing the center of the window to the center of the moon with 2 degrees of deadband.
The conversation you hear happening now between the astronauts aboard Orion and Artemis Mission Control here at Johnson Space Center in Houston, Texas. They are in the center of your screen, seated at the CAPCOM, or Capsule Communicator Console. That's Jenny Gibbons, Canadian Space Agency astronaut and Artemis II backup. She was also the lead CAPCOM for Expedition 63 aboard the International Space Station. The crew is requesting some attitude changes to the spacecraft to allow them to better image the moon, our priority for today. Of course, those have to be discussed on the ground before they are put into work aboard the spacecraft, so the team is taking some time to do so. You also heard Gibbons reference that we are in 2 deadbands. Deadbands are essentially keeping us in the lane in which we're traveling. If you're familiar with lane assist in your car, very similar in this case. We are now 10,870 miles away from the moon, traveling 1,066 miles per hour and 249,390 miles away from Earth. Again, we recently surpassed the Apollo 13 distance record of farthest humans have ever traveled. And upon calling down some words during that milestone, Canadian Space Agency astronaut Jeremy Hansen noting that he hopes that this record that they are setting today is soon broken by future explorers. This is Artemis Mission Control. We are standing by for the beginning of Lunar Flyby. Expecting that to start in just a few minutes when the crew will begin a warm-up discussion, preparing for the day. They will be capturing images along while discussing what they find familiar about the moon and what looks unexpected to them.
ちなみに、この写真は、ニコンの Z9 というカメラと、あとは 400mm の望遠レンズで撮った月です。これは、一番新しいやつかな？今はね、もっと近くにいると思います。400mm でこんなに撮れるのすごいよね。楽しみだな。どんな写真が届くかな。
We are currently 10,726 miles away from the moon. This view on the left side of your screen coming from the camera on one of Orion's solar arrays. Other conversation points while the crew are getting ready for their flyby today. They'll be looking to orient themselves using major landmarks and annotating their observations along with their discussion. They'll have 10 minutes for that warm-up discussion.
Houston integrity. We have two folks at the window deep in discussion talking about all of the awesome features that they're seeing. We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Oriental. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina, thanks. And you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Oriental. Great words.
This is Artemis Mission Control. That was the voice of Dr. Kelsey Young speaking with the astronauts aboard Orion as they begin their observation period and lunar flyby. NASA astronaut Christina Cook reporting their view of Hertzsprung Basin. The team here is looking for centered images of the basin at a full zoom, and they're hoping that the astronauts can image and describe the inner and outer rings. This is considered a degraded basin with a floor, rings, and ejecta compared to a younger Oriental basin. We spoke earlier with Julian Gross, the Artemis curation lead, about some of the terms we will hear the crew use today. One of those just called out, that's albedo, looking at surface brightness, or the amount of light a surface reflects. A few more terms that we hope to hear today during the crew's sit reps or situation reports include embaying. This refers to one feature that surrounds another. That usually is a higher relief feature.
Houston Integrity, one report from the crew at the windows. We can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing because, of course, the Earth is much smaller than the moon in our view, so you could think that your eyes focus for the darker sky, and that it means that it only has apparent brightness more than the moon, but since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
We're all going to be experts in lunar terminology by the end of the day. Another one we expect to hear is mare. These are dark regions paved or filled by volcanic deposits. You also can hear them called seas, oceans, lakes, or marshes, or other bodies of water. Again, we are live in Artemis Mission Control, but on the right side of your screen, that is the Science Evaluation Room, team members who have been preparing for this day for years. The crew has significantly darkened the cabin of Orion. This allows them better views outside the windows and fewer reflections from inside. They reported being able to see the moon and the Earth out the same window at this time. We are really hopeful to get those photos. Right now, this view on the left side of your screen coming from a camera mounted on one of the solar array wings on Orion outside the spacecraft. The crew is equipped with 80 to 400 millimeter zoom lenses.
月と地球が同じ窓に見えてるって言ったよ。すごいね。すごいね。やっぱりこの80ミリから400ミリのズームレンズ使うって言ってましたね。月と地球が同じ窓に写ってる写真とかもなんか、すごいよね。こんなのが多分そのうち届くよ。
The team continues their warm-up discussion. I should say the crew members aboard Orion continue their warm-up discussion. However, they are about to be prompted to move on to discussion number 2, which is near side and far side. Some of the things that they are looking to capture, the ground has prompted them to photograph anything that stands out to them and to compare the near side versus the far side mare in color, albedo, topography, and texture. They also want the crew to compare the appearance of rayed craters in the near side mare versus in the far side highlands. Of course, a reminder that some of the items that the crew, or some of the landmarks the crew are seeing today, is the first time that humans have ever laid eyes on those portions of the moon. In the targeting package, there are a few reminders of the crew. For the crew, there are time-sensitive observation reminders and science sit rep reminders.
Integrity. We have sit rep. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reed in window 1, having a great discussion. Christina's under window, I'm sorry, Reed is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off. And are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Science, do you have any questions for us at this time?
Integrity Science, Victor, very glad that you provided the first formal science sit rep, as these were indeed your idea. One follow-up question, any relationship between those browns and greens you described? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot you can see on the near side. There is a feature called, I believe, Burgess Alpha, that is equally or maybe higher albedo. apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
Understood, Victor, and good call to not bug the window team. Really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and that the bigger Mare off to the to the east was still dark, but maybe a 7-8. We still think that, but you are seeing color variation, albedo variation inside of Grimaldi as well, and that even on the west side there's still a very dark part of it. But it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to differentiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
このね、月の観測っていうのも、今回のミッションではとても大事なところなので、かなりね、これから打ち合わせが続くと思います。で、実際に、もちろん写真が届くのはダイバートだし、あと、カメラの映像もね、まだしばらくね、こんな感じで変わらないと思います。のんびり近づいています。私ももうずっとフライバイの瞬間まで配信はできないので、7時とかになっちゃうともうダメだから、見れる範囲でね、私ものんびり眺めていこうかなって思います。
To her right is Trevor Graff. He is one of 3 science officers. Those would be Kelsey Young, Trevor Graff, and Angela Garcia, who will also join us later for an interview.
Houston Integrity Science Integrity was able to get a view out of window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the t-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get 2 eyes on it, what jumped out at me was Vavilov. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light, the low sun angle. And so where the, Vavilov has that impact over the top of another crater, where the 2 craters intersect on the eastern edge. So on the side closest to Oriental, where the 2 crater rings intersect, the shadow there is the highest peak in the interior of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the t-shirt shroud from window 1.
Copy, we will do. Thank you.
Those calls coming from NASA astronaut Victor Glover. As we discussed, the crew is working in pairs at the windows. Right now, taking photos are Commander Reed Wiseman and Mission Specialist Jeremy Hansen. Serving as their support team are pilot Victor Glover and Mission Specialist Christina Cook. You're hearing those calls from Victor Glover as he is on that support team, and he is tasked with providing the science sit reps, while the two crew photographing and making annotations of the moon are in Windows 2 and 3. Windows 1 and 4 are available for the support crew to fly up to, obviously look at the moon themselves, and provide these science situational reports. The view on your screen is part of the lunar targeting package, and it's something that the crew can reference as they are flying by, but this is an animation. You also heard Glover mention Oriental. Oriental is a major feature that the team is interested in today, and it's known as the Grand Canyon of the Moon. Until this mission, the Oriental Basin had never been seen in sunlight by human eyes. Oriental Basin and its surrounding ejecta could fit within a straight line distance from NASA's Johnson Space Center, where we are at today, to Kennedy Space Center. This a live view in Artemis Mission Control in Houston, Texas, where the teams are monitoring all systems, not just for today's flyby, but on the spacecraft themselves. Again, this is a test flight, our very first flight of humans on the Orion spacecraft. This team has been This team has been monitoring the entire time of the mission, as well as we have been live the entirety of the mission, and we will be continuing to do so all the way through splashdown and crew recovery from the Pacific. This is a visualization from ARROW, the Artemis Real-Time Orbit website that you can also access at any time by visiting nasa.gov/track-Artemis, showing us that we are now under 10,000 miles from the moon, 9,948 to be specific, and continuing to count down. Again, our closest approach to the moon today should come about 6:02 p.m. Central, 7:02 p.m. Eastern. However, we will be out of contact with the crew at this time as they begin transiting behind the moon. At that time of closest approach, the distance from Orion to the lunar surface will be about 4,070 miles. Of course, these are estimates at this time, and we'll be sure to provide you with the official numbers once that closest approach has been reached. This shot live inside the Orion spacecraft, where our 4 crew members are continuing with their lunar flyby activities. They have just begun those activities really about 20 minutes ago, so we've got several hours of moon view opportunities. This is still a live view inside that capsule. However, you can see just how dark they have turned down the lights. Actually, they've turned them all the way off. There are a few LEDs that they cannot power off, but turning down these lights gives them better views outside of the spacecraft's windows while they photograph the moon. This also prevents any reflections from inside the spacecraft bouncing up on the windows and interfering with their photography.
これからね、月の写真を撮るので、宇宙船の中は真っ暗にしています。まあ、ね、外は夜っていうのも変だけど、真っ暗なわけだから宇宙空間はね、だから宇宙船の中を暗くして、 ガラスとかにね、反射しないようにして写真を撮るってことですね。で、まだ、だいぶ月へのね、接近っていうのは、時間がかかるので、一旦寝ようかな。一旦寝ようかな。ね。この NASA のサイトでね、現在位置とか見れる場所は貼っておきましたし、あと NASA のね、公式の YouTube で配信はこれからずっと続くみたいなので、そちらをね、ぜひ皆様ご覧になってください。私は行きたい。寝ます。寝て、普通にね、平日なので、見るけど、見はするけど、チラチラ見はするけど、配信はできないから、ちょっとね、見ながら、皆様もね、歴史的な瞬間をぜひ見てあげてください。じゃあ、一旦おやすみなさい。
Glover and Cook are serving as support crew. They are able to assist with cameras. They are also providing those situation reports, letting us know how the team is working